Tangent shifting. Tangent shifts. So when we're dealing with tangent shifts, the generic equation for shifting a tangent looks the same as the sines and the cosines. None of that has changed. When we graphed tangents yesterday, we graphed them with their parent function, and the parent graph of tangent always went through the origin. You had your asymptotes, which were half the period. Yes, sir. Oh yeah, absolutely. Yeah, and the way that I've been doing this stuff, by listing out all the points and everything, is exactly how it's set up on the test. It's labeled out for you what you need to do. And if you were doing that on your homework and all that, you're going to be fine. Okay? So your tangent function looks the same as everything else. Your A, your B, your H, and your K. Remember, H's go for your horizontal shift. Your K goes for the vertical shift. What's going to be messy with tangent, remember yesterday we talked about how it has asymptotes? When you have all the asymptotes, sometimes obviously you have to shift them as well, left and right. Your asymptotes don't go up and down, just they're already going up and down. I don't have to move them up and down. What's that? Yeah, the period doesn't change even after you shift. The period is still there. It just moves one way or the other. So I'm going to show you guys a couple ways of writing them out. I'm going to do that via the graph and then label your ordered pairs. And then I'm going to do ordered pairs to the graph. I'm going to go both ways with it. It's up to you which one works better for you. Some people find one way is easier than the other. It really doesn't make a whole lot of a difference which way you go. You're still going to get the same result in the end, which hopefully is a curve that looks like this. No. Let's start right with this one. So we have y equals -2 times tangent of parentheses x plus pi over 4. Gee, what do you think my first question is going to be? Label them. Yep, label them. Stay in the habit of labeling out all your stuff right away. A is -2. What is B?
1.
Good. What's H? Ooh, negative pi over 4. Very good. And K? 0, because it's not there.
So is H always absolutely?
Yep. Always. Always. All right. So now we know that the A value is -2. Our B value is 1. Now to get the period for a tangent function, remember your period is going to be pi over the absolute value of B. So what's your period for this? Pi. Bless you. Your original asymptotes. Remember, your original asymptotes are always going to occur at half of your period. So what's half of pi? Pi over 2. Now the reason why I write it as plus minus pi over 2 for your original asymptotes, because where does the tangent graph always go through for the parent function? It goes through 0.
Sorry.
It goes through 0. Okay. So now I start by draw. Hi, how are you? Now, first thing we're going to put on here are the asymptotes. Here's negative pi over 2. Here's positive pi over 2. Remember, that just means that the distance between these two is your period. It's pi. The parent graph of tangent always goes through the origin, so I know that I can put a dot here right away. And I also know that with my tangent graphs, that shift of where the changing directions occurs halfway between the asymptote and the origin. What's halfway between negative pi over 2 and 0? And what's way between 0 and pi over 2? Good. So here's pi over 4, negative pi over 4, and here's pi over 4. Your a value, all you have to do is mark it off. Now, since the a value is negative, what direction is this going? Is it going from quadrant 3 to quadrant 1, or is it going from quadrant 2 to quadrant 4? Second one. 2 to 4. Isn't it a slide either way?
No, because one, if you're going to that is one's going up and the other's going down.
Well, if I'm going the other way and looking
We're not
down.
looking that way.
Well, if I'm looking that way,
We're looking that
I'm looking that way.
But I want to look that way.
Then you'll be wrong.
Well,
So since your a value is negative, it's just going the other direction. Yes, ma'am. If it's positive or negative. Positive values, if the a is positive, it's always going this way. If a is negative, it's going this way. That's all. And now since this is the parent graph, we just dot it.
oh, yeah.
Okay? Now, remember there's a curve. It looks like it's a straight line between here because the points line up, but it should be a curve. I mean, I'm not going to yell at you if it's... Draw as close to a curve of it as you can. I mean, it's going to look like this. I mean, it's not... I'm not going to go to a ruler and say, oh, it's too straight. Because, you know, at this point in time, I know that you could do this and go, oh, I know all my stuff. I know that it's at negative pi over 4 and 2. I know it's at 0 and 0 and pi over 4, negative 2. And asymptotes at plus or minus negative pi over 2. What? Well, I want you to. Because, in all honesty, if you know all this stuff, that means you know what you did here. I don't care if it's like a Picasso or it's, you know, a Rembrandt or, you know, Michelangelo, Dali, Raphael, Teenage Mutant Ninja Turtles. All right, anyway, so now each one of these points has to be moved to the left pi over 4. Okay? That includes your asymptotes. So basically, when I start shifting all of my asymptotes and everything, I know I'm going to move everything to the left. So what I do here is I'm thinking about all of the fractions that we have. Every one of these fractions has pi in the numerator, including the shift. The shift also has pi in the numerator. So what I'm going to do is just, instead of saying negative pi over 2, I'm going to say negative 1/2. I'm going to shift it negative 1/4. So I'm asking, what is negative 1/2 minus a 4th? It's negative negative 3 pi over 4. Okay? That's the far left asymptote.
How do we show the
It's going to be difficult to do because that's why I'm going to ask you to list them. Okay? Because you're still going to label them. If you've got a different color, that's great. If you don't, you're still going to have to list them.
Can we do like soft like the actual?
Asymptotes are always dotted. And I know it's kind of weird. Now go to the other asymptote. The other asymptote was at pi over 2. If I take 1/2 and I subtract a 4th, what do you get? You get pi over 4. So now your other one is here. All right? Looks a little way off the scale, so I'm just going to kind of move it just a little bit. Obviously, this is no...
I was going to say that.
Yeah, well, whatever. So our other asymptote now is at pi over 4. So my new asymptotes, I just wrote them down because we just graphed them. All right. Now, to each one of these points, they all need to move to the left pi over 4. So, negative pi over 4, and I subtract pi over 4. So what's negative 1/4 minus a fourth? Negative half. So this one goes here. So I know that one will be at negative pi over 2. The y value did not change because there's no k value, so it's at 2. Instead of being at 0, it is now at negative pi over 4. Instead of being at pi over 4, it is now at 0. And all I'm doing is just, as I'm shifting my points on my graph, I'm writing down the ordered pairs. Connect the dots, la 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 la. And that's a shifted tangent. It is a messy graph. The tangents can get kind of messy, especially if you only have one color and your pencils aren't the cleanest and you have handwriting like an A like B. So.
That should be a song. April02.
What?
Song.
You know the song from Charlie
You
Brown,
know,
like,
picking up and I'm putting down.
I don't smell what you're stepping.
Don't worry.
I've never heard that before. I'm sorry.
no, she said I should be, because you know the song from Tarzan, people like me, you know, or whatever.
Yeah.
Yeah, that one, she was saying that should be a song, Ape like me.
I'm trying to figure out if I've ever. You ever heard a song called what?
No, it's
No.
just, no.
It's a song is like Tarzan called.
Strangers Like Me is what the song from Tarzan is called.
You would have to have seen Tarzan.
Are you talking like Johnny Weissmuller Tarzan or?
What?
The animated Tarzan.
What do you mean what? Johnny Weissmuller. He was the original Tarzan. He was like swinging
The Disney
gold
Tarzan.
medalist.
The Disney Tarzan.
I'm joking with you. No, I've never seen Disney Tarzan.
You should totally see the best.
Yes, it's being recorded. Look, a duck! Anyway. That's so scary.
Was that recorded?
Of course. Alright, so another one.
Isabella, our stupid comments are recorded.
What's that recording? Of course it's recording. Where is it?
Mr. Piscola. I think the hardest part is figuring out for like each like side cosine like what period has to go the e's are.
There you go. Try this one. Oops, sorry. We did that in the way. Y equals 5 minus tangent of 2 times the quantity x minus pi. Once again, as we start these problems out, you're always going to list out your A, B, your H's, and your K's. Figure out what your period is going to be. You don't have to worry about finding any amplitudes. You know what the A value is that's given to you. You don't have to change anything.
Oh, it's
Your A value is
negative 1.
negative 1. B is 2. H. How are you?
Duh.
I said, what's the H value? He said, pi. I said, how are you? I said, pi. Carl, that's it. We agree that your period is going to be pi over 2.
Yep.
Where are your asymptotes for the original? Very good. Your asymptotes, your original asymptotes, will be at plus or minus pi over 4.
Wait, how do you find asymptotes again?
Asymptotes are always going to, the original asymptotes are always going to be at half the period, plus or minus. because the period or the original graph for tangent always goes through the origin. So that means that if the period, so here it is. Since my original graph is going to go through the origin, the period is about the origin. So this distance is pi over 2. So this has to be negative pi over 4 and pi over 4. Does that make sense? And we do that each and every time with tangents. One other thing you might have noticed when I graphed this one, I kind of moved it over to the left a little bit because I know that eventually I'm going to have to go to the right because I have a shift to the right and I have a vertical shift as well. Okay? Your A value is 1 and negative 1. And halfway between a quarter and 0 is pi over 8 and negative pi over 8. So A is negative again. So that means it's working its way down from quadrant 2 towards quadrant 4. So your points are going to be at here, here, and here. Now in this example, I'm going to show you guys how I would do this if I'm just writing out ordered pairs. So your original ordered pairs are at negative pi over 8 and 1, 0, and 0, and then pi over 8 and negative 1. Your asymptotes are at negative pi over 4 and pi over 4. Do we agree? Excellent. All right. I know all that information just from this. I also know that my shift is going to be plus pi and plus 5 for all of the ordered pairs. Well, the easiest set of points right away to shift is going to be the shift at the origin. What's 0 plus pi? What's 0 plus 5? So that means the new one is at pi and 5. That's where my new origin, if you will, is. Well, the other one is, remember, the other ones are just repeated points now. The y values are always repeated. I'm still writing down 5 because you asked me. Only to start. Second ones aren't always plus minus. Okay. Now, here's where it gets interesting. The y values are very easy to add. 1 plus 5 is 6. Negative 1 and 5 is 4. Do we agree? Now, this is where most of you guys are going to get thrown for a loop. Once again, what I'm going to do here when I'm looking at negative pi over 8 plus pi. In my brain, I'm saying negative 1/8 plus 8 over 8. Because that's the same thing as negative pi over 8 plus pi. All I did is got a common denominator. Or in your calculator, negative 1/8 plus 1. Math, enter, enter. It'll spit out a new fraction for you. It's 7/8. So it's 7 pi over 8. Same thing here. 1/8 plus 8 over 8 gives me 9 pi over 8. All I'm doing is all of my fraction work to get my second set of ordered pairs before I plot them. It's just another way of doing this. Some people find this method a little bit easier. Same thing with my asymptotes. I have to add pi to this. So instead of adding, this is the same thing as negative 1/4 plus 4 over 4. Okay? All I'm doing is getting, instead of writing it plus 1 or plus pi, I'm getting rid of the pi and I'm creating normal fractions so you can work with them in your calculator or you can do them by hand. Remember, you just got to put pi back in it when you go to plot. Okay? So now, by having all of my shifted stuff written down, I can go ahead and take those. Well, my new asymptotes are at 3 pi over 4. I added pi to both of them, to both asymptotes, because that period stays the same. The distance between 3/4 and 5/4 is still a half. So the distance between 3 pi over 4 and 5 pi over 4 is still pi over 2. It's still the same distance apart. All I did is just messing with the fractions. So this distance is still the same. It's just 3 pi over 4. My new middle is at pi. We found it. To the left and to the right, I have 7 pi over 8 and 9 pi over 8, respectively. Because we did all that work just now by adding our fractions together, pressing math, enter, enter, and putting pi back in your answer. We also know what our new a value, or our new a values are going to be shifted towards, because we found that by adding 5 to all the other ones. So it's 1, 2, 3, 4, 5, 6. It's all the way over here. And there's your new graph. Okay? And that's your new graph. Yes, sir? No. You're adding your shift, not the period. Your shift is pi. Everything gets moved to the right pi. Yep. Because that h value is an x value. And then asymptote is an x equals a number. So this just gets moved over here. All right? So remember, it's -1/4 plus 1 gives you 3/4. You lost a quarter, you found a buck, you're up 75 cents. Okay? That's what we're looking at doing. We're looking at winning money. Yay! This is just another way of doing those problems. If you're okay by figuring out the fractions right away, you don't need to list them out to help you to start with, don't do it. But I'm still going to ask you to write out your ordered pairs before and after shift, as well as your asymptotes. You're still going to have to do the work. Some people just find it easier to work with the ordered pairs prior to plotting the shift. That's all. And it's up to you how you want to set it up. What do you got, Jake?
I just can't see the first asymptote.
3 pi over 4.
What's the second one?
5 pi over 4.
No, right after.
Oh, 7 pi over 8. Remember what I've got here. Oh, sure, no problem. What happens here is that you've got your asymptotes from your original, -pi over 4 and pi over 4. I added pi to both of them, replotted them. Then I went to all my original 3 ordered pairs, added pi, added 5, added pi, and I just put them through.
So could you just do that for like the -pi over 8 and pi over 8, you add pi to those?
That's what I did. That's how I got 7 pi over 8 and 9 pi over 8. And all I'm doing is, if you're not doing the fraction stuff in your calculator, just, yeah. Okay. It's the same. It's a 14.2 section, Ken. It's the it's a 14.2 in your book. The tangent problems shift. I think it's like 44 to 49. Okay, there's like 6 of them. One more?
Yeah.
We got time for it. Yeah. Well, what's your shift? Yeah. So you subtract pi. Now, what I did here is I did all of my fraction work prior to plotting anything. I listed out my original stuff. I listed out my original set of ordered pairs, negative pi over 8 and negative 3. I shifted it. I subtracted pi and added 1. So I get negative 9 pi over 8, negative 2. 0, 0 becomes negative pi, positive 1. Scrunchy case. Yes.
Why is K1? I thought it wasn't there, it just was there.
I wrote it in with a plus 1.
Oh, I did not notice that.
You didn't notice that? Sorry. I wrote in a plus 1 there because I wanted to put a K in there because the problem didn't have it originally to it. So if you did everything right without the K value, don't worry about it because it wasn't there. Okay. Also, pi over 8, subtract pi from that, you get negative 7 pi over 8. Now, by shifting all these things through the ordered pairs wise, now I can go to my graph and just start filling in the blanks. I know that my far is at negative 9 pi over 8. Closer one is at negative 7 pi over 8. In between them, it's negative pi. In between, oh, I put the asymptotes there. Oh, I'll just do this. That looks horrible. And then instead of being at negative 3, I'm at negative 2. 0, I'm now at 1. And now I'm at 4. And here's your shift. Okay. Remember, plot and pair it, shift it. Like I said, I'm going to give you guys 6 of these. No, it's not a waste of trees. 8, 45, 44, and 49. Okay.